take us that too much time. So, okay, now we're recording. Welcome to today's tutorial. We're planning to do question papers, but I just realized there's quite a lot to cover, but it's fine. We'll get back to question papers once we know a bit of serious C++, right? So we'll do the SS semester test 2 SSA. That's the question paper we're gonna start with. If you want to start practicing it now, you can do that. That's okay. But for me, I'm not gonna touch on that yet because, like I said, there's quite a lot to explain, like a lot. So we're gonna need, and our sessions are gonna become a bit longer when you do past papers. But I have the past papers here. We'll get to that when we get there. So I think we're supposed to start with things like functions, right? So I think we can start talk about functions. Also talk about we're gonna have to go back and talk about constants. I forgot to cover constants. Yeah, I should normalize like creating a schedule or something of the topics that we're gonna be talking in that session, so that I don't forget. Yeah, I totally forgot about constants. Yeah, constants are very important. So let's wait for code blocks to open. Then we'll start with constants, then we cover functions. Then after functions, what else comes after functions? Probably things like type, def, and record structures. So I'll see if it's possible to cover all of them in the sessions. I'll see. If it's not, then we'll finish it off in the next session. Then after that session, then we'll start with question papers. So I'm going to create a console application. So this will be about mainly functions, but also talk about constants. So I'm going to go to manager, main.cpp, right? So before we start with before we start with the functions, let's go back to variables, right? If you remember, we talked about how to declare variables. You simply put in the data type first, then followed by a space, right? This space is very important. Then after the space, you put in the name of the variable. And we're going to normalize using what we call camel case. I hope I did talk about that. I think I did. Yeah, I forgot the other sessions, but I think I did cover that. So the data, just a simple variable, right? I'm going to say int pi, right? Not necessarily an int. Let's make it a double. Pi is equals to 3.14. So this is what we call a variable. Why is it called a variable? If you break down the word variable, right? You break it down. It includes two words, vary plus able, right? Vary just means change, right? Vary just means change. So that change in full, a variable just means that it's something that's able to change. So we store that information, but that information we're still able to change it. Hence, it's called a variable because it's able to vary or able to change. So you can think of vary as a synonym for the word change. So it's able to vary or change. But if you think about it mathematically, right, pi is a value that does not change. So we cannot allow the user to to change our pi value. Because if you leave it like that, if the user comes down here and suddenly decides that pi is now 2.17, right? Suddenly the user just decides pi is now that value. If you try to build and compile this, it's gonna run well, perfectly fine. Because this is a variable, it means that you're able to change it. It varies, right? It changes. But we don't, what if we have certain information that we want the user not to change or not to be able to change? That's where things like constants come into place, right? A constant, you basically declare a variable the exactly same way. The only difference is that before the data type, you put in the word const. Right before the data type, you put in the word const. So if you want to create things that do not change, right? So if you want to create variables that do not change, right? You'd have to use, you must use the keyword const, right? I'm just going to leave these notes there. So you're going to use the keyword const. Why the keyword const? Because the word const, right? The keyword const itself, it comes from the English word constant, right? Meaning that thing is constant. It's fixed. If you remember your constants in science, right, in physics, those constants that you use in your calculations. Actually, those constants are called constants because they do not what? Change. They're fixed. You use the same value everywhere. You don't ever change that value. So therefore, the developers or the people who made C++, they're like, oh, so if it's a constant, something that's not going to change, why don't we take the word from constant, just only take the first 5 letters, right? Then use that in C++ to create something that's a constant. So you're going to say const, right? Followed by a space, followed by the data type. By the data type, and then space, followed by the variable name, and then followed by an equal sign, and then followed by the value, and then semicolon. Why is it always this case? Because remember, a constant is something that does not change. So this is the only way you can declare constant. This technique, this is the only way. You can never ever declare constant the way you can declare variables. Remember variables, right? Initializing it on the same line is optional. You can just create the variable like this. Then in the next line, you say pi is equals to 3.14. That's allowed. That's variables because they vary, they change, right? So they're prone to change. So that's fine. We're gonna leave that as it is. With constants, you need to use the keyword const, meaning that this value is constant. So if you say something is constant, you need to provide the thing that is constant, which is the value. So therefore, constants are always initialized on creation. When you declare the variable, that's when you initialize it. If you don't, you're gonna get errors. We'll demonstrate this in our code now. So I'm going to create a constant, right? So const double pi is equals to 3.14, right? 1.14159, something like that. So there's pi, right? So you might be like, you might ask yourself, these variables are the same, right? Line 8 and line 13. No, they're not. For one, number one, this is small letters, PI. These capital letters. C++ views them as totally different variables, even if you name them the exact same way. If you change one thing, even if you made it like this, maybe it's a small p instead here, it still thinks they're two different variables. Even if you made this as a small I, it still thinks they're two different variables. That's C++. As long as the case, we call it the case, whether it's lowercase or uppercase, if the case is different, it thinks these are totally two different variables. So that's why I'm using the word pi again here, and it's not going to complain. If I go and build here to compile my code, you see that there's no error. There's no error on this green line. So that means everything is fine. But remember, we talked about it being a constant. It does not change. So if you go into the next line, I don't know, maybe you forgot that it's a constant. And for some weird reason, you try to change it. You say maybe it's no longer 3.14, it's 3.15, right? Then if you try to build, you're going to get an error. You see, there's the error here. So this error just simply means that you're trying to change something that was not supposed to be changed. It's not supposed to be changed. It's unchangeable. It's fixed. It's a constant. So you see here, it will tell you that you must try to somewhat read the error, right? Understand errors. My bad. Hey, this thing, I'm zooming in too much. So it say the error is that assignment of read-only variable pi, meaning that it's meant to be read only. You shouldn't you shouldn't change it. You should only call the variable or use the variable, not to assign it a new value. That's not allowed because this variable, it's meant to be read only. You can only read it. It's like you can watch but don't touch. For example, you go to a car dealership, you want a car. They'll tell you can look at the car but don't touch. That means you're only meant to look. Don't touch it. So it's like the same thing. It's a read only, meaning you can only read the variable. Basically, you can only see out the variable or use it in equations. Maybe you're calculating the area of a circle, pi r squared, right? So you can use it in that equation because pi is used in that equation, right? It will allow you. But if you try to change pi, that's where the problem is. Remember, we said variable constants are variables that do not change. So here you're trying to what? Change it, which is very wrong. It's not gonna work. No matter how much you pray, it's not gonna run. Your code will not run. So don't ever do that. Then we have right. We have what I call a constant, right? This const here, which is just it's mainly what is this? It's mainly for what is this thing? It's mainly for single values I can put it in that way, single values, right? Basically, there's no multiple things in the value, in the number itself. If you look at here, right, the number 3.1, that number, it has multiple things. It has a dot there. That dot, you can't say that's one thing because we have a number here, then we have a dot, then we have other numbers after the dot. So it's not actually representing one thing. So const wouldn't be the right one to use here. C++ is another one called const expression. So there's two types. There's const expression and const. The const expression is for when you actually want to store some expression. It could be an equation, it could be anything, but it's some expression. So, but then it's an expression or that's stored in a variable of which that variable, once you've stored the value, you cannot change it. So you can say const expression, right? Which is basically const expr. This expr stands for expression, right? They just removed all those words. And then this const stands for constant, right? Meaning it's a constant expression. It's an expression. By expression, right, I want you to think of expressions like this. If you have things like curly braces, right, basically you're initializing an array with curly braces, maybe to these numbers, right? This is what we call an expression, right? Or for example, you have a double 3.4. This point over here, this dot, now makes this whole thing as an expression instead of a single value. So here we use the wrong one. It's supposed to use const expression here. It'll still work if you use const. But then you realize that sometimes when you start using const in the wrong place, it's not gonna work. So for example, let me make a simple example, right? So I'm gonna say const double. No, let me say int equation, right, is equals to 3 times 4. Let's try to build that. Okay, it didn't complain. But then if you try to initialize, right, to try to make it an array. So let me see. Nah, the example's not gonna work here, yeah. But let's say you try to use this expression. It will crash because you're supposed to use a const expression. You'll get an error, but there's two types of errors that have occurred here. The type that I'm using and the fact that this thing is an expression. So expressions, you use them when you don't, basically, let me put it this way, right? For you to kind of get the whole idea. If you have things like a double or float or curly braces to initialize an array or equations, maybe you're multiplying and adding, use a constant expression because that's what we call an expression. If you have things like integers, right? If you're creating integer constants, just use the word const to, because it usually, const in a way you can picture it as like you're representing one thing, one single thing. For example, if I create a constant for, and these people, you keep Leaving and entering. What's going on? Is it Wi-Fi? So you have let's say the number 3, right? Or 42. Let me just use 42. If you look at 42, right? 42 is just number. It has no special characters or symbols. For example, there's no dot today. There's no curly braces. There's no comma. There's nothing. So it doesn't count as an expression. So therefore you'd use const. If you have things like dots, curly braces, special symbols, then just know that's an expression. So you have to use const expression to create that constant. So this is the difference between the two. With const, just mainly use it when you have integers, right? Basically, you're representing one value, and that value, that number, it has no special symbols. And I forgot to tell you about something about naming constants, right? When you name your constants, you must capitalize you must write it in uppercase letters. So if you wrote it in this way, equation like this is wrong. You should write it in uppercase letters, equation, right? It's in all caps. That's the rule for naming constants. All caps, all capital letters. Then you have pi. As you can see, pi, I was already following that rule. What if you have more than one word, right? I'm gonna traumatize you guys for just for a bit. Life of pi, right? If you know, you know. Yeah, we all didn't like this. So life of pi, right? Let's say that's the constant. There's multiple words. I have life, that's one word. I have of, which is another word. I have pi, which is another word. You separate the words with an underscore. That's the rule. So you put underscores here, but then don't forget to capitalize each letters. So life of pi, right? So that would be my constant, right? That's the only rule you need to know about how to name them. Make sure you use all caps, capital. You use capital letters to name your constants. You don't, you're probably gonna lose marks. Just keep that in mind. You're probably gonna lose marks. So make sure you use the right way to name things, right? To name the constants. So this will be a constant expression. This will be a constant, just a normal constant. Then now we're gonna talk about I don't know if wait, we haven't even talked about loops, right? Yeah, did we talk about loops? I doubt. Even if statements, we no, yeah, we left. Yeah, there's quite a lot to cover. I think the last thing we did was on if statements, if I'm not mistaken. Then I was like, I'm gonna continue with switch statements from that. Then switch statements, then the ternary operator. I'm not sure, or maybe I'm mixing them up. I'm thinking about com sci 2A students, but yeah, I'm not sure about that. Can someone confirm what was the last thing we did? Did we do if statements is the last thing? And did I cover like everything? Like ternary operator, conditional operator, and yeah, all the other things, did I cover them? Or I only left with if statements? Can someone update me? Can someone you can unmute and speak. The thing is, yeah, my memory is a bit foggy right now. I can't remember. Did we last do if statements or what? Was it? No, it was pointers and
No,
arrays.
we didn't do it. You said we're gonna start from there.
The if statements, right?
Yes.
Okay, yeah, it's fine. Then we're gonna do if statements, then functions. Then I think we can end our session there. If statement, like all this, we call them selection statements, right? When they're all together, they're called selection statements. So this will be, yeah. So I need to talk about if statements. So we have this, right? We have our constants. We understand the constants, right? If your number or the things you're trying to initialize on the right-hand side of the equal sign, it has special symbols like a dot, curly brace, comma. That's an expression. So use const expression. If it's just integer, just know it's const. Simple as that. Then I'm gonna open Notepad++. We're gonna go back to maths a bit, right? So we're gonna talk about maths a bit. So this was Java. So I'm gonna change the language to okay, it's already in C++. So if you remember in maths, right, there's a topic called logic. If you still remember that topic, if you didn't like it, yeah, you have to know it. That's what we use here. So we have three operators, right? No, it's four. So we have AND, OR, XOR, and then NOT, right? So we have all of these different operators, right? In C++, we call them operators, and they're called logical operators, right? These are the operators we have that we're going to use in C++ when you're dealing with logic. And if you still remember logic, right? Remember logic very well. We had truth tables whereby you either get back a true or a false. It's the same thing, exactly same thing in C++. And in order to store this result, whatever we get back, that's true or that false, it's stored in a data type called bool, right? So we're gonna make use of this data type called bool. Why is it called bool? Just a short history. Because it was named after the person, the reason why you're doing logic, thanks to this mathematician over here. He's the one who came up with logic. You can go Google him, read the history about him if you're that interested. So they took his surname, then they just simply removed the E. And then they made the B a small letter, and then now you have bull. So that data type was named after him, the one who invented the maths based on logic, which ended up being such a success and such an important thing in our society that yeah, they had to commemorate him and name the data types after his name, after his surname. So that's the data type we're going to use. It's bool, which just simply stores only one thing, true or a false. In C++, it's not entirely true, right? Let me tell you something about C++. C++ is not an easy language. It's not entirely true that you can only store true or false. You can actually store numbers, which is integers. Why can you store numbers? Because remember, I talked about zeros and ones, whereby 1 represents a true state, meaning there is electricity, right? That's a 1. And then we have a 0, which represents a false state, meaning false, there is no current or electricity. There is no electricity, right? There's an absence of electricity. So it will be represented by a 0. But in C++, to represent true, right? It's a C++ thing, but it kind of took from this whole concept of bits, zeros and ones, that in order any basically in C++, if you want to get true, it's any integer other than 0. That's C++. Any integer other than 0 gives you true. So that means I can say -1, -10, it will still give me true, as long as that number is not 0. So you can actually, you see, I'll demonstrate the if statements that you can, in an if statement condition, you can put an actual number. C++ will translate that to a true or false. So we have the logical operators, right? Basically going back to maths. So how do you represent them in C++? So I'm gonna sort of like make a table here. So this is the math way, right? And then this is the C++ syntax. In C++, you use two AND symbols. They're called amper. It's kind of hard to pronounce that word, but it's called ampersand, right? So this is how you spell it, ampersand, right? When a single AND, right? It's called an ampersand. So we just basically mean it's the AND symbol. But then that's how you represent in C++. The OR, you put in two pipes, right? Or two lines. These two straight lines. This represents OR, right? Then XOR, exclusive OR, so it's in full, it's called exclusive OR, whereby you use that cap there. If you remember probability, exclusive OR, it means that you only get it true based on events that are mutually exclusive, meaning that the both events cannot occur at the same time. They are mutually exclusive. So this is where they getting that whole name. The X stands for exclusive, which in full means mutually exclusive. And then the or is similar to or, but it's kind of extended, right? In a way. And then the not in C++, here, that is represented using an exclamation mark. And then remember, this one just simply negates. Basically, it gives us the opposite truth value. I'm taking you back to maths. Like I always say to my students that the students in the past, if you don't like maths, don't go to ComSci. ComSci is a maths degree. If you didn't know, now you know. You see that the same topics you're learning there, you're also learning them here. So there's no way of running away from them. So I would advise you practice your maths every day because you're gonna meet some of these things, whether it's in final year or honors, you're gonna meet it. So master your maths, study very well with your maths, especially maths 1B. Yeah, you better be mentally prepared for that. So we have something that we call truth values, right? Truth values is basically true or false. They're called truth values. So when I give you a statement that says the not negates the truth value, I mean that if you have a not true, you're gonna get a false. If you have a not false, you're gonna get a true. It negates, it gives it the opposite. It's like antonyms in English. Just to remember antonyms. Revision again. So this is the symbols that we use. So what about and what about or what how do you get back how do you get back a truth value of true? So let's start with and, right? I'm gonna just enforce you to master it by just using the C++ syntax. So when you have and, this I'll just say the statement. Yeah, this I'll just use the word statement. You can swap the word statement with sentence if that makes you understand better. The statement is true. I'm gonna use the textbook terminology for logic, right? If and only if. I'm sure you've heard that quite a lot. Revision, if and only if. I'm sure you've heard that quite a lot. The statement is true if and only if both statements are true. So basically, the overall statement, right, which is the overall statement, is true only if and only if both statements are true. So, for example, um, what can I make? What example can I make? If both statements need to be true in order for the whole statement to be true. So, for example, I tell you that I'll buy you takeaway if you get 100% the semester test two, something like that, right? So, number one, there's two conditions that need to be met. You need to pass, you need to qualify, right? Let's say qualify, and after you've qualified, your ST2 mark should be equals to 100. Remember, we talked about this. When you have two equal signs, they mean we are checking if the value on the left-hand side is equal to the value on the right-hand side. So that's that. I don't know. The thing is, I kind of, you see, when you have, the thing is, ComSci is similar, ne? If I say that I taught you something and I actually didn't teach you, you should correct me and say, no, you haven't taught us. Because these same things that are there in Java, ComSci 2A. So I might make a mistake and assume that I taught you and I didn't. I think I'm not sure about this equal. If I didn't talk about, yeah, I think I did. No, I didn't. I doubt I did. I think it was ComSci 2A. So if you qualify and your semester test two is equals to 100, then you get what? Lunch on me, right? So two conditions need to be true. Number one, it needs to be true that you qualified. And it also needs to be true that you got 100%. That's the only way you can get that thing. Basically, that's the only way this overall statement will be true. when both statements are true. By both statements, I mean the statements that are separated by the end. That's what we mean. Then when you have or, right, when you have or, the overall statement is true if and only if at least, right, at least one of the statements is true. Maybe now I give you another, maybe I give you another different option, right? I say that you either have, I don't know, maybe I say you either have a semester mark, right? I'm going to call it SM. If you have a semester mark of is equals to, let's say it's at least, right? So greater than or equals to, I don't know, 95. Let's say that's your semester mark. Or you got 100% in semester test 2, then I'll buy you lunch. So basically, it's one, at least one of these conditions will be true in order for you to get lunch. So that means maybe you might not have gotten 100% in semester test 2, but your semester mark is 95. Maybe in semester test you got 98. But that means your semester mark will be at least 95. That provided that you pass semester test 1 well, then you should be at least 95. That means you qualify to get free lunch. Even if it's both, that's the thing about or if at least one of them is true, at least. That means even when both are true, it's still true because that means at least one of them are true. So the overall statement would be true even if it's both, they're both true. Basically, it means that you have at least 95% on your semester mark, and you also got a semester test 2 or mark of 100%. You still get lunch because the condition was that you need to meet at least one. If you meet both, perfect, you're a genius. But the condition was that you need to meet at least one. So that's the or, right? It works exactly the same way as it works in maths. Even in C++, it works that exact same way. Then you have exclusive or, right? Which just simply means that the overall statement is true if and only if both statements, I would say both statements are mutually exclusive. Let me just put it this way, are mutually exclusive. If both statements are mutually exclusive, meaning that they can occur independently, like we can view it in that way. Basically, that thing can happen on its own, that one can happen on its own, but they cannot occur at the same time, right? So maybe I come up with another condition, right? I'm just trying to go, um what is motivate other students for second semester so that they know if you do well, you get free lunch from say. So I'm gonna come up with another one. Let's say I want to use exclusive or to demonstrate the whole notion of two independent they cannot occur at the same time, right? But then this one is gonna be kind of a bad example. You see what I mean by that. So your semester mark, right? This one, let's not say that I'm gonna buy you lunch. Let's just say we're just demonstrating two events that cannot occur at the same time. So you cannot have a semester mark of at least 90% and then exclusive or, and at the same time, Wi-Fi. Okay, I was having a network issue there. Now it's back. I don't know what's going on with this Wi-Fi. So as I was saying, these two events cannot occur at the same time. You cannot have a 90% semester mark and yet you got 0 for semester test 2. It's impossible. These two events cannot occur at the same time. So therefore, this would result in a true. The answer for this statement would be true because both statements they cannot occur at the same time. Basically, they're gonna have different truth values, right? But then it might not necessarily be true. This would be a very bad example, like I said. It might not necessarily be true. Let me think of another one. Yeah, let me think of a simpler one. Let's say is raining, right? Just imagine there's a variable called is raining, and then is sunny, right? Let's assume that in a perfect world, right? We live in a world whereby if there's rain, there's no sunlight. Just ignore that one whereby if it's raining and it's sunny, that means the monkeys are getting married. Just ignore that one when it's both. Pretend does not exist. So if it does not exist, right, that means if it's raining, it cannot be sunny on. It cannot also be sunny on outside. If it is sunny on the outside, it cannot also be raining at the same time. So that means these two events are mutually exclusive. They cannot occur at the same time. So if they indeed do not occur at the same time, then the answer will be true. That's what exclusive or means. Then we have the last one, which is the not, which just simply negates the truth value, right? This is basically simple, right? If, for example, not eating, right? If you negate not eating, that means you're doing the opposite of eating, which is not eating, right? And then if you say not okay, let's say let's use truth values in the second example. If you say not true, this will give you false. Because think about it, if someone says no, your statement is not true, they're basically saying your statement is false. They're equivalent. Those two things are the same thing, just a different way of phrasing it. So the negation, all it does is just simply negates, or the not operator simply negates. It gives the opposite. So if you say not true, you get false. If you say not false, you get true. So these are the different logical operators, the operators that you guys used or you were taught in logic. Then we're going to talk about operators that they're called relational operators. I hope yeah, the thing is, there are some of the topics that I talk about in with first years. I also talk about it in with second years. You will notice that when you get to second year, you realize some of the things are similar. So let's talk about relational operators, right? So relational operators, they also return a bool, meaning a true or a false. So that's why I'm explaining them now here, because we're going to talk about if statements. So you have, let's start with something simple, right? You have greater than or equals to. This just means greater than or equals to. Then you have less than or equals to. This just means less than or equals to. Then you have this one, which just simply means less than. Then you have greater than, which just simply means greater than. For mathematicians, right? If you want it to be mathematically correct, they say that less than, they actually say it's strictly less than or strictly greater than. That's how they phrase it in the mathematics textbook. If you check, they use the word strictly less than, meaning it's strict, it's not including that number. So you can double check on your textbook, you see what I'm talking about. Then we have two equal symbols. This one they just check for equality. Basically, is the left hand side equal to the right hand side? That's what this is the one to check. If you use one equal sign, C++ assumes you are putting a value into a box, into a variable, which is not what we want, right? We want to compare. So I need to use those two equal signs in order for C++ to know, oh, you don't mean that one, you mean this one. And then we have, what else do we have? Mm, yeah, almost forgot. We have not equals to. Remember the not, we talked about the not, right? The not operator. And then there's the assignment. So when you use them together, it means not equal to. So basically you're trying to make sure that something is not equal to something. That's when you can use this one. So basically, if it's not equals to this, then this will be the operator that you use. They are called operators because they operate on operands. You can think of it like doctors, right? All of these operators, right? Think of them as specialist doctors. And then those doctors, they operate on people, right? In this case, these operators, they operate on operands or numbers. So what do I mean by that? So it's a simple number like 1 plus 2. In this case, the plus would be what we call the operator. Basically, the doctor. I'm gonna use the doctor example so that it kind of clicks. So the operator, meaning the person who's doing the operation, is the doctor. Right? In this case, this doctor specializes in adding numbers. That's what this doctor went to study, to add the numbers. Then the things you're adding, they're called operands. Basically, the things you're operating on. In this case, the plus is operating on this number 2 and on the number 1. So the things that the plus is operating on, they're called operands. Operands, right? So the values, the operator, I'm teaching you also English here. The values that the operator operates on. Remember, I made the doctor example. Think of the plus as like a doctor. He specializes in adding numbers. We also have a doctor that specializes in dividing numbers, in multiplying numbers, all those things. So this will be the doctor, which is the operator, the plus operator. Then these are the operand. Since it's on the left-hand side of this operator, right? This one is called a left operand, right? Left operand. And then that other one, since it's on the right-hand side, is called a right operand. And then we're going to have an operator in between them. Then we're going to have a right operand. Teaching you proper English here. So this will be the right operand. And then our operator would be this plus. Uh, yeah, so this is pretty much it about operators, right? Then, yeah, I guess you understand the terminology. Operands are the things or the values that you're operating on. It could be variables. Remember, you're allowed to add two variables together. They're still operands. So we understand the relational operators, right? There's relational operators. So now we're going to talk about arithmetic operators. Just a quick revision, right? So arithmetic operators, these are the operators that do arithmetic. We talked about one of them, plus. Then we have the star, which just simply means multiplication. That's how you represent multiplication in C++ by putting that star. And then you have the addition. And then we have division, right? This division, you need to be very, very careful, right? This division, it actually does two types of divisions. We have integer division and double division, right? Basically, division with two integers and division with two doubles. There's two different kinds. You need to be sure of which one you want. If you do the integer division, you get back what we call the quotient. Taking you back to mathematics. If you have two integers, right? You have a numerator and the denominator. Then you're gonna, and they're both integers. You're gonna get back what we call a quotient, meaning the remainder is thrown away. But what if you wanna see the full number? Then you have to cast. You have to do something that we call casting, or basically treat one of the operands as a double. So here I'm also going to have the percentage symbol, which just simply means modulus, right? By modulus just simply means remainder. It gives you the remainder. If integer division, this one gives you the quotient, the percentage symbol gives you the remainder. And then we have what else? Subtraction. I don't know how I forgot about that. Subtraction. And then, yeah, these are all the operators that I can think of right now. Yeah, there's no other operator. So these are all the operators that are there in C++, right? And if you still remember board mass, it also applies since it applies in maths, it also applies in comp sci. Like I said, if you don't like maths, don't go to comp sci. Comp sci is a maths degree. You see that also so far we're doing like revision, and all the things you're taught in high school, they're being applied again here. Board mass, some they use mm, PEMDAS, right? Yeah. Is it PEMDAS? Yeah. Some they call it PEMDAS, right? By PEMDAS, they mean you start with the parentheses, which is the brackets. Then you go to exponentiation, meaning to the power of. Then you go to M multiplication, D division, A addition, S subtraction. So it's up to you which technique you wanna use, but either way, as long as you understand order, that is order. If you want to change the order, remember you can just change it by putting what? Brackets. Because board mass always starts with what's inside the brackets. Taking you back to high school again. So we have these different operators, right? The mathematical ones, right? You see these arithmetic ones, right? They give us back a number because they're meant to give us a result or after calculating, right? So these ones, they're not gonna apply right now in our practical in the session. I mean, the ones that are gonna apply is these ones over here. These are the ones we're gonna use. So let's make an example, right? Let's talk about if statements. Remember, we talked about the Boolean, the logical operators, right? And, or, exclusive, or, not. We talked about all of them, right? Now we're gonna use them in C++. So assume that, right, you have let me go back here. Yeah, I should normalize trying to keep the sessions short. Let's stick to selection statements. So we're gonna do if statements, switch statements, and the conditional operator. Then we leave it at that. Then next tomorrow session we do functions. Then after functions, I think we can do past papers. No, we still have record structures. Yeah, we'll see. I think I can just do everything tomorrow. Functions and record structures and the other things that are left, like type def. You might need that. It might come in handy. Might. It does by might. Simply means that it's not a must for you to use it, but it does kind of help make your code easy to read. So let's talk about if statements, right? We have what is an if statement? If statements, right? We are simply checking if a specific condition has been met, right? By condition, it's like, and we do, to be honest, we use if statements on a daily basis. Before you go out, don't you do an if statement to check if it is raining? Then you wear a raincoat, excuse me. Then you wear a raincoat. Then you take your umbrella. If it's raining, right? That's an if statement. If it is raining, wear a raincoat or grab an umbrella. If it is sunny, wear a dress or wear shorts. That's an if statement. You've been doing if statements your whole entire life. So now you are writing it in code, telling a computer to do that. So you simply use the word if, right? Meaning if this thing is true. So if what thing, this is what we call the condition. Or sometimes they call it a Boolean expression. By Boolean expression, because it's an expression that gives us back a bool, which is a true or false. That's why they might call it a Boolean expression. So this is how you spell it, Boolean expression, which just basically means that it's something that gives us back a bool, meaning true or false. So this condition over here must give us a true or false. So if it is true, right, then you do something when it's true. So do something when it's true, right? That's when you do that. You do something when it's true. So we have that. Then it might look weird, right? Just know C++ is a lot of things, right? There's a lot of techniques in C++. To be honest, you can actually write your if statement like this. For example, if is raining is equals to true, right? Let's say that's what you're checking. Then you say C out raining, right? Something like this. This is allowed in C++. I know you might not have seen this if statement like this, but this is allowed. In C++, when you have an if statement that only has one statement, by one statement we mean that any one thing that is a semicolon. That's what we call a statement in C++. Basically, in English, it's something that we call a sentence. So if you have one statement within the if statement, you can omit or remove the curly braces. They're optional. But if you have more than one, for example, I have see out is raining, I have see out wear jacket. I have now two statements. Therefore, I need to put in the curly braces, or else if I leave it like this, right? C++ is gonna assume this. It's gonna think, oh, this one is on its own. This one. It's not in the if statement. Then this one is the only one that's in the if statement. So which is a problem because that means that it will always run C out this one, even though it's not raining outside. So which is a problem. So that's why I'm teaching you different techniques so that you understand. You only leave the curly braces when you have only one statement. If you have more than one, you put the curly braces. Now, since I have more than one, I'm gonna put in the curly braces back. So the curly braces, it's up to you in what way you structure them. You can put it on the same line where the if statement is, right? So you put a space there, you put it the opening curly brace there. Then the closing curly brace, you put it here, right down there. Don't be doing spiritual things and your code, hey, students, hey, students would have code like this. I just don't get it. Like, what goes in your mind when you have code like this? That looks like this. Do you see how ugly this is? And you expect me to understand this? If I was your tutor, I would give you a zero, Shem. I would have no sympathy for nonsense. If the lecturers keep on telling you that make sure your code is structured well, follow coding guidelines. There's rules for this thing. You can even get fired in a company for making your code look ugly because now you're gonna make a lot of problems for the company. They're gonna other people when they're hired. It's gonna take them longer because now they have to fix your code so that it looks neat first. Once it's neat, then they can try to understand your code. Do you see how much time is being wasted? And in the industry, you see, this is 64 lines. In the industry, you're looking at about 1.2 lines per file, and you might have 300 files. Who's going to go and fix every file for you? So I'm going to reiterate, I'm going to say this again. Do not write ugly code. Do not ever write ugly code. You can make sure everything is neat. If you're having problems with writing neat code, whatever, follow that tutorial of how to install Visual Studio. I think Visual Studio does force you, it does put the things, yeah, it forces you, Visual Studio, to style. That's how important styling is. It might look insignificant to you, but that thing of styling can determine whether you're getting a job or not. So follow the rules. There's two ways you can write an if statement with curly braces. It's like this, whereby the curly brace is on the same line as the if keyword. Then the closing curly brace is on its own line, not on the lines that are within the statement. Or you can choose the technique that most C++ developers use, which is like this. This is preferred, right? Because it's clean, straight to the point. You put the curly brace on the next line after the if keyword. Then after the curly brace, don't do spiritual things and put your statements like this. Because I'm honestly tired of seeing ugly code. It pisses me off. It gets on my nerves. That's how serious this thing is. Make sure your code looks pretty. This is if you notice my code, I've never had a session whereby my code looks ugly. I'm sure you should have asked yourself why is it doing that? It's very important. There's rules. There's even a whole page explaining this thing. Don't make if statements this way, make them this way. Don't do for loops this way, make them this way. There's a whole instruction. It's a whole textbook on this thing. Try it now. You don't you fail to do it now. I'm telling you, you're gonna be left behind when they're doing interviews. They see, okay, you can code, but your code is ugly. It's all over the place. It makes it difficult for other people to read. Because when you write code in the industry, right, you're writing code not just for you, for your colleagues, for people you're working with. Because once you implement a small feature, for example, your app must supposed to support card payments. They give you that task. You do card payments. Then you send it to the next person who's gonna do something else. Maybe the app has a feature to recognize your face. Someone does that part only. So they're gonna have to read your code. If your code is all over the place like this, do you see how frustrating this thing is? Look at how this code looks. It's like this person has no order, there's no structure in their life. They don't know where they're coming or going. So try to do the right thing. I hope I've explained enough on that thing. No more writing untidy code. Trust me, even Dr. Strungu gets pissed off when he sees that. He might not tell you direct, maybe he might, because he's a genius, he's a hard work. So he expects you to work hard and read the documentation and understand that C++, you don't just write like, I don't know, you write like this is your, I don't know. Just make sure you don't do that. Or just, if you're trying to send me code, just make sure you think twice because of what I just said now. Yeah, I think I might start enforcing it. Before you send code, make sure it looks pretty. That should be a requirement now. So there's the if statement, right? So this if statement, it only checks for when it's true. Only when it's true. It doesn't, what about when the condition is false? Because the statements within this curly brace, you see this curly brace over here, right? There's something that we call scope. It defines something that we call scope, meaning that these two statements, they only belong to this if statement, basically for on that condition. The moment you get to this part over here, these statements will no longer exist, right? So what if these two statements that I've written here, okay, no, not those statements, but what if the condition that I've checked here, it's actually false, meaning it's raining outside, meaning it's sunny outside. If it's sunny, then I can have an else. So you can, if you're having an else if else statement, right? There's two ways. You can structure it this way. Remember, I talked about it. Make sure there's spaces. You see here, this is also not allowed. You see that there's no space after the F. After this F, there's no space. That's incorrect. You need to have a space there. After this closing round bracket, there's no space, right? Incorrect. You need to have a space. So this space is over here and this space is over there. They're very important. Then even here, when you write your else, space before you type the else. Don't just type else immediately after the, no, you put a space first, then else, then space again, then if, then space again, then round bracket, whatever, if you are writing else if statement. But we're still talking about the else. The else, it means that you're going to have an else case here, then curly brace, then closing curly brace. Do you see how organized this if statement is? I expect all your code to be like this. So else, if it's not raining, then it is sunny. So I'm gonna say see out sunny, right? It's sunny outside, right? I'm just gonna say sunny. So this will be the if statement. So this is how it works. This is how it reads. If is raining is true, meaning it is true that it's raining, right? If it is true, then rhyme these two lines, the two lines that are between this curly brace and this curly brace, right? All those, execute all those lines, meaning that it will only output raining and wage jacket only if the is raining variable has a truth value of true. If it has a truth value of false, then it's going to execute the else part because we said else, meaning it's the opposite of this. So else meaning it is not raining. If it's not raining, then it is sunny because that's the app we are making. So it's going to output see out sunny, right? Then this is it. This is an if else statement. There's other statements we'll talk. I'll extend on this just now, but let me demonstrate this in code. So this is the section about if statements. All right. So if statements, I'm gonna have if, Then a condition was the condition. But before I have the condition, I need to create a variable called is raining. Remember, I talked about the bool type. I'm dealing with if statements here. So I'm going to need to create a bool type, call it is raining is equals to true. We don't, because there's no mathematical formula to determine if it's raining. Unless if you're checking the degrees, if the degrees are greater than or equals to these degrees, something like that. So let's do the check, right? So I'm going to say if is raining is equals to true, right? I don't like this style. Some people like it. I don't. I like this other style, whereby you put the curly braces on the same line like this. And I want you to know how neat my code is. So bool is raining. Then I'm going to say see out. It is raining. Then I'm gonna, and another thing, right? You see where I'm typing my C out, there's a space here. This space is also very important. C out, it is raining, backslash n. C out, I'm gonna say if it's raining, I'm gonna say wear a jacket. No, let me just say grab an umbrella. Grab an umbrella. Under my umbrella. Reminds me of Rihanna. So you're gonna grab your umbrella, then else. So this is the preferred way to write if statements, but it's up to you. Maybe you like this style. There's also this style, right? Pay attention to all the spaces that are there. All the spaces. And look at how aligned my C out statements are. I can literally draw a line there. You see that on the same line. That's exactly how you should be writing your code. Neat. C out, it is sunny outside. Because that's the app. It assumes that if it's not raining, it is sunny. So I'm gonna run it, and you should see an output of it is raining, grab an umbrella. So you see, it is raining, grab an umbrella. Why? Because the is raining variable has a truth value of true. In C++, you can actually avoid writing it in full like this. Because what C++ does, right? When you pass in a variable in the condition part of an if statement, it goes to that box. Remember, this is still a variable, it's still a box. It goes to that box with the label is raining, and then it checks what truth value is inside of it. For example, let's say in this case we have true. So it says, oh, true. Then true equals to true. Yes, it is equals to true. Therefore, the overall result to be true, because true is indeed equals to true. So the final answer will be true. Then it's going to check the statements. But we could avoid all those checks by just simply writing is raining. So that you see that it kind of reads like English. If is raining, then do this. So it kind of reads like English. Like I said, when you put in a variable especially if you just only put in a variable as it is, you should only put in variables that are Booleans, because in that case, we can calculate a true or a false. In this case, my variable meets that condition. It is of type bool. So that means it stores true or false. Then C++ is gonna go to that box with the label is raining. It goes inside the box. It checks, is there true or a false? In this case, there's a true. So it's going to run this part. So if I undo this and then I leave it back to the way it is, you see that it's gonna work exactly the same way it was working. But then now my code is a bit shorter. You see, it still works. It still shows that it's raining, grab an umbrella. But if I change this to false, right? Remember, this is the part that runs when the condition is false. There's the part that runs when the condition is true. Basically, we're depending on the result of this. If it is true, run this. If it is false, run this. That's what the else means. Then if it's false, right? So it's gonna check if this is false. So this is not true. So therefore I need to go to the false part, which is this. So it's gonna output it is sunny outside. So I'm gonna undo this and put back the variable. My output that I'm expecting is that it should say it is sunny outside. Go play or something like that. I could have added more text, but I'm not gonna do that. it is sunny outside. So there's that output. So it is, my if statement is indeed working. Then we can also have what we call else if statements, meaning that, remember this else, right? It depends on only on one condition. But what if I want to check multiple conditions, right? So for example, I'm gonna create another bool, right? I'm gonna say is sunny, and I'm gonna set it to true. Then I'm gonna do an else if, right? Meaning, but an else if, basically what it means, an else if, right? It checks the first if, the condition. If it is true, then it runs. If it's not, then it checks another different condition. That's what the else if does. So its syntax is like this. It's if some condition, right? Then you have when it's true, then you have else if a different condition. It needs to be different from the first condition. And you can have as many else ifs as you want. You can have another else if, then another else if. And also at the end of the day, once you're done, you can also have an else. So you can mix them around. So you can have an if followed by an else if, and then at the end of the day, you're gonna have an else. Because why would you put an else there? Because it might be the case that it's none of the conditions above. So that means I'd have to accommodate that and put an else. So I'm just gonna do an else if. So else if is sunny, then it should go outside and work. So now in this case, it works a bit different. It's gonna check if it is true that it is sunny. Here's gonna check if it's true if it's raining. So you see that is different conditions that it checks. True if is sunny. And I'm gonna share the code. I'm gonna zip the code and send it in the group. Don't worry about the code. I know some of you want to see the examples. So the bowl is running, is raining, is sunny, and then we can also put in an else. So you can say else. So else, what would be the else? Else, maybe, I don't know. That means it's not sunny, it's not raining, meaning it could be windy, right? Could be in autumn, could be windy. So I'm just gonna say it is windy, right? So I'm just gonna assume it's one of those, right? And you're gonna remember I put false for is raining. So it's gonna check here, is this true? No, it's not. Skip. Check the next condition. Is this true? Yes. Then it's gonna output it is sunny outside. But if both were false, it was going to output it is windy. So let's test it out, right? My output should be it is sunny outside. And indeed, that's the output. Then I'm going to go back here. I'm going to change this to now false. So they're both false, meaning that it's going to skip here and also skip here. Then it's going to go to the else part, meaning all of the above. No matter how many conditions you had, it doesn't matter. All of the above, if they were all false, then C++ executes the else part. That's how the if statements work. Then I'm going to build and run. So you see it is windy. That's now the output. Then I'm going to leave that there. So let's go to, yeah, I feel like I took a lot of time explaining this, but it's fine. It's fine. Seems like we're going to have quite more sessions. Let me see. Yeah. If only the Wi-Fi didn't take a take and whatever, we could have been a bit far. Then I'm going to explain, let me just explain conditional operator. Then we will continue with switch statements. And yeah, just remind me in the group. I might forget because I'm teaching different modules, so I might forget. And things are similar. You still have else if in Java too. So in my mind, I might be like, oh, I did teach first years most if statements. Can't know. I taught second years. So just always kind of remind me what it's supposed to cover. In our next section, we're supposed to cover switch statements and functions. Just remind me in the group chat tomorrow. So here we're going to talk about the conditional operator. So what is the conditional operator? It's basically an if-else statement, but in one line, right? So let me show you what I mean by that. So let's say you're trying to find a maximum, right? So let's say you have int a is equals to 72. And then you have int b. Okay, I don't like this way of initializing. Let me initialize it this way. 88, right? Then I'm going to have a max variable. Okay, let me call it maximum. Let me just write maximum in full. If in code blocks and you type in you're trying to come up with a variable name and it's highlighted, just know it's part of C++. Find a different find another name. So that's why I'm calling it maximum here, because I saw that it's highlighting, meaning it's already part of C++. I'm just going to initialize the maximum to 0. Then I'm going to do comparison because I want to find a maximum. Then I'm going to check if, let me see. Yeah, I don't want to do that. Let me do this. Let's assume, right? So I'm going to initialize maximum to be the value of a, of the variable a, meaning maximum is going to have the value 72. Because I want to find a maximum between 72 and 88. I choose randomly. I can set it to B. It's fine. I just chose random. Then now I want to update maximum because I want to find a bigger number between the two. So I'm going to say if my maximum, right, variable, right, it's the value that it has currently happens to be less than the value stored in variable B. If you want, you can write it in vice versa. If you say B is greater than the current maximum, doesn't matter. People have different ways of thinking. Maybe you thought of it in this way. If B's value is greater than the current maximum, maybe this sounds better. So if B's value happens to be greater than the current maximum, then we need to update our maximum because that means apparently we don't have the maximum. We said B is greater, so we need to update maximum to have the value of B. And then we can have an else. Else, if that's not the case, meaning this is false, then the maximum would just be A, right? The maximum would just be the value A. Because if B is not greater than the maximum, we can only assume that maybe A is greater than the maximum. So it can be one of those. This would be the formula. Then we can simply output our maximum. So C out max. And then this is our maximum stored inside the variable maximum. Then output an end of line character. So the output should be 88 because that's the maximum. So you see there's the maximum, 88. So it is getting the right maximum. But do you see how many lines? You see starting from line 38. 1, 2, 3, 4, 5, 6, 7, 8 lines. Just to find a maximum. We can do better. There's something called ternary operators, right? Basically, it's a shortcut of if statement, but it's different from an if statement. You see, an if statement, you don't get back a value, right? You just simply run statements when a condition is true. With the ternary operator, you actually get back a result. So let me show you how it works. Since we getting back a result, just like calling a function that returns something, we're going to assign whatever that conditional operator gives us back to a variable. So this is the formula. So this will be the condition, and then a question mark because we're asking this question over here. It's a that's why I put in the question mark, because just like in maths, if you remember, not maths, in English, you had a question mark. Even in your home language, Pedi, Tsonga, Sotho, whatever the home language was that you're learning in high school, there's also question marks, right? Because you're asking a question. Then you have the true part, meaning when the question is true, and then you have a false part, meaning when the question is false, or the condition. So what's the condition? I'm checking if A is greater than B, right? It's up to you. Remember, don't cram. You can say if B is greater than A, it's up to you. But I chose to say A is greater than B. If A happens to be greater than B, then in the true part, remember this operator, it gives you back a number, something. You can return here a string, a char, a boolean like true or false, or a double. You can return anything. You don't write cout statements, It gives you back a value. You put values here, numbers or strings. Just you put a value there. So the value that I want to put is A, because if A is greater than B, then I should get back the number A, because that means that's my maximum. So C++, the way it works, right, is going to ask, is this true? If it is true, this is the true part. So it's going to take A and store it inside maximum. We need to make sure the data type of A is an int, right? Because the variable we're storing the result in is an int, is of type int. So we need to make sure we return integers here. Then the false part, basically when this question is false, if this question is false, that means B is the one that's greater than A, right? Therefore, I need to return back B because B is greater than A. Therefore, B, since B is greater than A, it will be stored inside maximum. Do you see now how many lines I saved myself? You see, gone. And it does exactly the same thing. But all of those lines are gone. That's the ternary operator. It's called, I like to use ternary, right? Or conditional operator. That's what it's called. I think for you guys, right, it's called a ternary operator in the textbook. For ComSci 2A, I think it's called conditional. That's the difference. But you can use the names interchangeably. So if I try to run this, remember, expect our maximum to be 88. Let's test it out and see. You see, it still works. 88. You might think, maybe say, good luck. Let me change B to something else. Let me change it to 12. So the answer, the maximum should be 72, which is A. So let's run it. Yeah, 72. So there's no lag here. So this conditional or ternary operator works. And you can extend it to whatever, but I don't want to complicate that stuff. I just want to give you a simple one. You complicate it when you get there, when you're ready. So yeah, this will be the conditional or ternary operator. I think I'm going to end my session here because I don't want to bombard you guys with too much information. So this is where I will end the session. I'll save the code, then zip it and send it in the group. So this will be if statements. Tomorrow we'll cover switch statements. Out of the selection statements, right, we're only left with switch statements. We covered the conditional, we covered the if statements. Now we're only left with the switch statements and functions. Then a bit of the other supplementary stuff. So yeah, I think I should end the session here. Yeah, so let me stop recording. Yeah, I don't want to bombard you guys with too much information. There's a lot to absorb